Okay, question number 2 is show that 1 minus cos 2x over 2 sin 2x is equal to k tangent x, where k is a constant to be found. So let's first prove this one. It's given that 1 minus cos 2x over 2 sin 2x is equal to k tangent of x. That is what we have to prove. So first take this side, left hand side. Okay, let's take the left hand side. It is 1 minus cos 2x over 2 sin 2x. Now the result that we have to make, it don't have the double angle. It has the single angle and is tangent. Obviously we know that the tangent is sine divided by cos. So first of all, it means our numerator we will try to convert in sine, and the denominator we will try to convert into cosine. So for that you have one formula is sine of 2 theta is equal to 2 sine theta cosine theta, double angle of the sine. And secondly, we know that cos of 2x has three formulas. Cos 2x is equal to cos square x minus sine square x, or it is we can write it as 2 cos square x minus 1. This is equivalent to 1 minus 2 sine square x. So in this case, I will use this third formula in place of cos 2x. The reason is I have to make tangent, and in tangent obviously sine I need in the numerator. So that's why I will use this formula, and in the denominator I will use this formula. So in place of cos 2x I will write 1 minus cos 2x is 1 minus 2 sine square x over 2 sine 2x. In place of sine 2x I will write 2 sine x cos x. Okay, now we have to simplify it. It will become 1 minus 1 plus 2 sine square x divided by 4 sine x cos x, and cancel with 1, and now this 2 cancel, it will become 1 over 2, and 1 of sine will cancel with that. So sine over cos is tangent of x. It means the value of k that we found is 1 over 2. So the first part is done. We completed that. We have to prove where that this can be in this form, where we found the value of the k as well. And then part B is saying hence solve for theta greater than 0 less than 90 degree. That one. Now if you look at this one, whenever hence is used, it means you can use the previous part. The result that you obtained in the previous part you can use here. It means 1 minus cos 2x over sine 2x, we know that is equal to 1 over 2 tangent x. Right now we proved that one. So it means in its place we can write it in terms of theta also, because 1 minus cos 2 theta over 2 sine 2 theta, in its place I can write that result. So for part B, let me first write that is given that 1 over it is 9 1 minus cos 2 theta over 2 sine 2 theta is given equal to secant 2 secant square theta. Okay, it's given. So the result that we right now we prove that we know that this factor is equal to 1 over 2 tangent theta. So in its place write that one. In terms of theta, that was in x. So this is in terms of theta. So write it in terms of theta. So it will be 9 into 1 over 2 tangent of theta equal to 2 secant square theta. And now this will become 9 over 2 tangent theta equal to 2 secant square theta. And this one is a trigonometric equation, and we want to solve it. And to solve the trigonometric equation, what we need, we try to convert it into single variable form. Into single trigonometric ratio. This is tangent and secant. So I will convert it into one form. And that we can do. We have the formula 1 plus tangent square theta is equal to secant square theta. So if in place of secant square, I will use that one. My complete equation will change to tangent. So it will become 9 over 2 tangent of theta will be equal to 2 into 1 plus tangent square theta. And then let's simplify that one. It will become 9 over 2 tangent of theta equal to 2 plus 2 tangent square theta. Multiply with 2 on both sides. I will have 9 tangent of theta equal to, this will become 4 plus 4 tangent square theta. And then it will become, take the tangent also to the other side. I will have 4 tangent square theta plus 9 tangent of theta plus, sorry, it will be minus tangent 4 theta, because when you will shift it to the other side, so it will be minus 9 tangent theta plus 4 equal to 0. Now, if you can do it here in two ways. One is you can suppose that tangent is equal to something and make it a quadratic and then solve that quadratic. Or otherwise, directly also you can take that one. For example, if you compare it with the general quadratic, this is the general quadratic, ax square plus bx plus c equal to 0. We call it, this is quadratic in x. So this is also, look, square term without square and a constant term. So I will say this is quadratic in tangent. When you solve this quadratic equation, so we get x is equal to minus b plus minus square root of b square minus 4ac over 2a. So in this case, as this is tangent in this is quadratic in tangent. So when I will solve it, I will get tangent. So it means you can say this is your a, the coefficient of the square term is 4, constant term b, the coefficient of x term is minus 9, and constant term is c, that is equal to 4. So using this formula, when you will solve, it will be now tangent of x, not x, because this is quadratic in x, this is quadratic in tangent. So that's why you will write tangent of x is equal to minus b plus minus square root of b square minus 4ac divided by 2. Now solve it. So tangent of x will become minus b, which is minus 9 plus minus square root of b square minus 9 square minus 4 into a into c divided by 2 into 4. So first the square root part you can solve. Tangent of, sorry, it is theta and not x. Tangent of theta will be equals to, now let's solve the square root part. And make sure now change your calculator into the degree mode, because in this question it's given that we have to solve it in the degree from 0 to 90 degree. So that's why change your calculator into degree mode. Also later we need that. It will be minus 9 square minus 4 into 4 into 4. So it is square root of 17. So that will become 9 plus minus square root of 17 over 8. So there are two possibilities now. Possibility will be tangent of theta will be 9 plus square root of 17 over 8, and the second option is tangent of theta will be 9 minus square root of 17 divided by 8. Now in this case, let's solve it first. Just it will be 9 plus square root of 17 9 plus square root of 17 divided by 8. So it will be 1.64038. It's a positive value. If you take this one, for example, if you take here the negative sign, the result is also positive value. In both the cases, the value is positive. Okay. So, and we have to solve it for from 0 to 90 degrees. I mean, our results will stay in either cases because, sorry, in that case, if I will say is positive value, and tangent is positive here in the first quadrant and in the third quadrant. So in that case, we just have to solve from 0 to 90 degrees. So just it means you will just find the principal angle. You will not go for the other value. As both these values are coming in the first quadrant, but if for complete solution, we look for the principal value and then we go for the other value. So in this case, don't go for the other value. Just principal value will be the value of the angle that we need. So in this case, your theta will be, in this case, tangent inverse, and make sure calculator should be in degree mode. So I will say, for example, in the first case, tangent inverse, that is 9 plus square root of 17 divided by 8. So it is 58.63, 58.6333 degree. And in this case, if I have to find, so now you will put the value, the negative value. Here the sign should be negative, not the negative. So 31.366. So on. And your answer should be to one decimal place. So convert it to one decimal place to each one. It will be, in this case, theta will be 58.6 degree, and in this case, it will be 31.4 degree. And both you can see these values are in the first quadrant. So that is. But if the domain is changed here, accordingly, you will go to the other quadrants also for solving that one. And one more thing, some students, what they do, they just put the values trial and error method. They use numerical method, that is called. That will be, or graphical method will not be acceptable. So you must have to show this, use this method to solve this one.